Everybody, it's Mrs. Harbin. We're doing video notes 11-2. So we're going to be calculating pH, POH, hydroxide, and hydrogen ion concentration. So we're putting math with acids and bases now. Okay, you have to know some equations and you have to know how to use them. Okay, so let's get busy. Read your book. Section 19.2 has some great pictures, diagrams, practice. And look, you can get bonus. Woohoo! Alright, read and do it if you want the bonus. Alright. So, guess what? Water is wet. Yeah, we know. So, what's really in water? Water is really a mixture of water, hydrogen ions, and hydroxide ions. How can we write that? Well, here's H2O. All right. It's really in equilibrium with H plus ions and OH minus ions. Okay. And because water molecules always are hitting each other, okay, sometimes when they hit each other, an H plus and an OH minus form because it breaks the bond. Okay, so this is really what's in water. So if water is neutral, anytime one of these breaks apart, you get one of those and one of those. So you have an equal number of those and those because they all come from water. So it's a balance of H plus and OH minus, which is why it's neutral. Equal amounts of the hydrogen ion and the hydroxide ion. So pH is relating the molarity of an acid or a base, well, actually an acid, to the number of H plus ions, which is, remember, these are the same thing. H plus ions and hydronium ions are the same thing. So molarity is capital M, and that's a unit of concentration. pH, memorize this formula. pH is going to be equal to the negative log of the hydrogen ion concentration. Right? So, how do I know the hydrogen ion concentration of an acid? Well, if it's a strong acid, then every single particle of that acid breaks into ions. Remember, strong means it breaks apart, totally ionizes. So if you know the concentration of the strong acid, you actually know the concentration of H plus because all the strong acid turns into H plus. Memorize these 6 strong acids. Okay. So we can figure out the pH of a strong acid by using this formula. So the pH of 1 molar HCl, well, we would say pH equals negative log, so plug the negative sign, the log button, into your calculator and put 1.0 and hit enter, and you find the pH of 1 molar HCl is 0. Okay, that's a very low pH. This is, remember, 1 molar or higher is concentrated, and it's a strong acid. What is the pH of 0.15 molar HNO3? Well, first of all, hello, I'm an acid, so we know it's an acid, and we know it's strong because it's on the list of strong acids. So all you have to do is say, well, all of this 0.15 molar HNO3 breaks up into H plus ions. So the pH is the negative log of 0.15. Plug it into your calculator and make sure you're getting 0.82 as the pH of that solution. Okay, so not only can we tell it's an acid and it's concentrated and it's strong, we can tell its pH by plugging it into this pH formula. Okay, why pH? So why don't we just talk about the hydrogen ion concentration? Well, the reason is that the numbers used for concentration are sometimes 1.4 times 10 to the negative 10th or 0.001. So these are small numbers, but a pH scale takes this power of 10 and makes it easier to talk about. pH helps us get numbers that are a little easier to talk about. So that's why we use pH. What is POH? Well, wait, what's the, okay, so pH is the hydrogen ion to the power of something. Okay, so pH is hydrogen ion to the power of something. So what's POH? It's hydroxide ion to the power of something. And the number you get is actually sort of like the power it's 2. Okay, if everything is in water, because back to here, remember, water has this and this in it, and those are equal in water. If everything's in water, then an acid actually has more H and less hydroxide, because this stays in equilibrium. Okay, so as the pH is going up, the POH is going down. So POH is the negative log of hydroxide. Hey, that looks familiar. What's the difference? Well, if you have pH, you get pH is negative log of hydrogen ion, so POH is negative log of hydroxide ion concentration. And then the relationship between pH and POH is they always equal 14. So here's formulas to memorize that we're going to be using. hydroxide ion concentration is equal to the concentration of your strong base, because every strong base makes 100% hydroxide. Okay, what are strong bases? The group 1 and 2 hydroxides. Make sure you memorize that. So here we go. What is the pOH of 0.022 molar NaOH? Well, first of all, this is a base. How do I know? Hello, not hello. Oh, I'm a base. And I'm from group 1. Sodium's from group 1 on the periodic table. So this is a strong base, which means all of this that goes into the solution breaks up totally into this. So the concentration of OH is 0.022. So what is the pOH? It's the negative log of 0.022. So what's the pOH? Well, negative log of 0.022 is pOH. So the pOH equals 1.66. All right. Now, if that's pOH, what is pH? Well, here's the formula. So if I know pOH, I know this one, I want to know that one. pH is going to be 14 minus 1.66. The pH of that solution is 12.34. Well, what does that mean? That means it's a base because it's above 7. And so this is a base, and there's the concentration of the base. This is going to be a basic solution. Okay, acid or base? Base. We want the pOH, strong or weak base? Strong, because it's a group 1 hydroxide. So that means all of this hydroxide that goes in breaks up into ions. So the concentration of hydroxide is the concentration of 0.0001 molar, because all of the lithium hydroxide breaks into hydroxide ions. So now that we know that's 0.001 molar for the pOH, we take the negative log of it, and we get, make sure you practice putting this in your calculator, we get 4. All right, so the pOH is 4. So what's the pH? Well, 14, pH equals 14 minus the 4 for the pOH is 10. So pH is 10. pH of 10 means a base. This is a base. This is the concentration of the base. So it makes sense that the pH is high because we have a base. Okay. Now, what if we know the pH or the pOH, but we don't know the concentration? Well, it works backwards. You use this formula. The concentration of hydroxide and the concentration of hydrogen are just taking the number 10 to the negative pOH for hydroxide, the number 10 to the negative pH for hydrogen ion. So we know the pH is 2.3. That's an acid solution. How do I know? pH less than 7. But what is the amount of hydrogen in that? Well, we have to say, well, if I take 10 to the negative 2.3 on your calculator, 10 caret negative 2.3, I find out that the concentration, the hydrogen concentration, is working backwards with that formula. Remember, it's a negative log of H plus equals pH. Well, then if we want this, we have to bring the negative over, and we have to 10 caret because that's the log function, and we get 0.005 molar. Okay, if we're asking for a concentration, it's the molarity. Okay, what is a hydroxide concentration if pOH is 11.1? Well, the hydroxide concentration is 10 to the negative 11.1. How do you plug that into your calculator? 10 caret negative 1.1, calculator buttons. We find out that the hydroxide ion concentration is 7.94 times 10 to the negative 12 molar. Okay, anytime you're looking for a concentration, it's a molarity. All right, so we can do that, but then we have to also be able to work back and forth between all four things. All right, what is the H plus concentration if pOH is 9.4? Okay, so note what we're given. We're given OH, but asked about H plus. Those don't directly relate, so we got to use two formulas to calculate this. I think the easiest one to do is to say, well, we know pH plus pOH equals 14. Make sure you know that. Right? So if I plug in 9.4 for this, then I find out that 14 minus 9.4 is 4.6. But what does that 4.6 represent? It's the pH of the solution. Okay, so this is an acid, pH is 4.6, but now we want to know how much hydrogen ion is produced in that acidic solution. So then to find the H plus, I have to say 10 to the negative 4.6. 10 to the negative 4.6 is 2.51 times 10 to the negative fifth molar. Okay. So if the two things you're asking about aren't directly related with one formula, you got to use two formulas to calculate them. All right, so H plus and OH plus minus are opposites of each other. In acid, there's more of this. Acid, there's more of this and less of this in acid. In neutral, they're equal. H plus equals OH minus in water, okay, or neutral things. In acid, there's more of this, so less of that, okay. So as H goes up, OH goes down, and vice versa. There is a formula that relates them, a calculation. The concentration of hydrogen times the concentration of hydroxide always equals 1 times 10 to the negative 14. This is called a KW. It's a constant for water, okay. So if I know one, I know this one, I can figure out the other one by saying, okay, so if I know this formula, I know that 1 times 10 to the negative 6 goes in for hydrogen, X goes in for hydroxide, goes 1 times 10 to the negative 14th. So then to get X, I have to divide by 1 times 10 to the negative 6th. And I find out that the concentration of OH minus is going to be equal to 1 times 10 to the negative 8th molar. Okay, so this formula, if you know one, you can figure out the other. All right, hey, this tells us POH. That has to do with hydroxide. We want H+. Ruh-roh, what can we do? Well, POH can get us to hydroxide. So hydroxide concentration is going to be 10 to the negative 6.77. Why? Because it's the in the opposite of the log function. So we find out that 10 to the negative, I gotta turn my calculator on. 10 to the negative 6.77 is 1.698 times 10 to the negative 7th molar. That's for hydroxide. This question asks for what is hydrogen. Well, now that I know hydroxide, I can figure out hydrogen. So the hydrogen concentration, okay, so this is hydroxide, X is hydrogen concentration, and we know that 1 times 10 to the negative 14th is the constant. So we divide that by 1.698 times 10 to the negative 7th, and we find out that 1 to the negative 14th divided by 1.698 times 10 to the negative 7th is, so the hydrogen concentration is 5.89 times 10 to the negative 8th molar. Okay, so because this and this aren't directly related, we had to use two formulas to get it. So what are we learning about here? The pH scale and how to calculate the pH of a solution. How acidy is your acid and how basey is your base. Okay, so here's our neutral, here's our acids, here's our bases, and you can see the different things on there. Some of them are common household items. Bananas rock. Okay, so pH of 7 is neutral and doesn't hurt. Okay. Extreme pHs are dangerous. So if we're extremely low or extremely high, that's dangerous. For instance, the pH of lye is pH of 14 is a substance called lye. All right, that's the stuff that is used to dissolve bodies. It's a base. Okay. pH of 1 would dissolve your teeth in days. Okay, so you don't want that. And pH of 7.4 is blood. Your blood's actually slightly basic, and it makes vampires happy. Okay, so here is a diagram that if you want to put down in your notes, you can, and then you can use it. If you want OH minus, you can find the 10 to the negative POH gets you it. What else gets you it? The see, this is that water constant divided by the hydrogen concentration will get you hydroxide concentration. So the way to get hydroxide concentration is coming in from the arrows pointing to it. Okay, if you want POH, follow the arrows pointing to POH. So take hydroxide and negative log it, you get POH. Take pH and do 14 minus pH, and you get POH. Right? So here are the formulas that if you start here, you use to get there. Follow the arrow. So if you start here, you do 14 minus that to get POH. If you're given POH and you do 14 minus POH, you get pH. So follow the arrows and use that formula to get what's missing. Okay, so more review and more music. Hello, I'm an acid, friendly, and I give H+. These are the four formulas that we talked about in this mathematical ways to calculate. If you want pH, plug in negative log of H+. If you want POH, plug in negative log of OH minus. If you want pH or POH and you know the other one, use the 14. And if you want concentration and you know the other one, use 1 times 10 to the negative 14. and indicators change color at different pHs. Alright, so read chapter 19 and do the bonus to help you understand chemistry. Peace out. Make sure you know these objectives, and then we'll go to Baltimore. Just kidding, we're not going to Baltimore.